Hello friends, welcome to the next problem. The problem over here says L equal to 0 raised to n, 1 raised to n, n's greater than equal to 1. Think over it for a second and see if you can solve the problem. See if you can find the logic for the problem. This problem is very much similar to the very first and the second problem. So let's see how to go about this problem. So friends, first and foremost thing, the language over here is 0 raised to n, 1 raised to n, which I can further frame as 0 raised to n, 1 raised to 1 plus n, which I can further frame as 0 raised to n, 1 raised to n plus 1, which now I can write as 0 raised to n, 1 raised to n followed by a single 1. So now let's understand a input over here. So maybe I have 4 zeros, then I should have 4 ones and that one differently which I have drawn over here. Precisely both are the same one. So now what is going to be the logic for it? The logic now remains exactly same as that of the first problem. First 0 x, first one y. First 0 x, first one y. Keep on repeating the same thing. So I say I'm going to make the first 0 as x. I'm going to bypass everything till I get the first one and I'm going to make it as y and move to the left. Then bypass everything till you get the first x. Keep the first x as it is and move to the right. For the first 0, make it as x, bypass every 0, bypass y till you get the first one, make it as y and move to the left. Bypass y, bypass all zeros till you get the first x, keep the x as it is and move to the right. Make the first 0 as x, bypass everything, make the first one as y, move to the left. Move to the leftmost thing till you get the first x, keep the x as it is and move to the right. The moment you get a 0, make it as x, move to the right, bypass all the y's. The moment you get the first one, make it as y, move to the left, bypass everything till you get the first x. Now keep the first x as it is and move to the right, and now you stand over here. Now over here to the right of the x, we are unable to find a 0. That signifies that my zeros are over. So as per the logic of a raised to n, b raised to n, my ones should also be over. But my friends, this problem is not talking of that logic. This problem says 0 raised to n, 1 raised to n, followed by a 1. So now, what are we interested is in checking whether before I come across a blank after bypassing all of the y's, is there a single 1 present? So now, as we are standing over here, I'll be keeping y as it is and keep on bypassing it, moving to the right. And if I get a single one, how that I'll be showing you when we draw the implementation part of it. But the moment you get a single one over here, I say make it as y and move to the right. And now if to the right of this y I'm getting a blank, now I say you can go to the final state, else you cannot. So my friends, I repeat, to the right of this y there should be a single one, and to the right of this single one which was converted to y there should be lot of blanks available. Only if this is the scenario, only if this is the case, then only the input should be accepted, else rejected by my Turing machine. So let's see how the machine works on this problem. So I have an input like B 0 0 0 1 1 1 1 followed by blank. So friends, we are in state Q0. I get a 0 I'm going to make it as x and move to the right. So the moment I get a 0, make it as x, move to the right to state q1. In q1, for all the zeros, keep it as 0 and move to the right. In q1, the moment you get a 1, make it as y and move to the left. So the moment you get a 1, make it as y, move to the left to state q2. In q2, keep on bypassing everything till you get the first x. So in q2, as of now I am getting a 0. I keep the 0 as it is and move to the left till I get the first x. The moment I get the first x, I say keep the x as x and move to the right to this particular state. Now in state q0, I get a 0, I make it as x, move to the right. In state q1, I get a 0, I bypass it. In state q1, I get a y, I keep it as y and move to the right till I get the first 1. In state q1, I get a 1, I make it as y and move to the left. In state q2, I now get a y, I keep it as y and move to the left. In state q2, I get a 0, I bypass it and move to the left. I keep on performing this operation again and again till I get the first x. For the first x, I will be keeping it as x and moving to the right, and I now stand over here. Now the transition diagram is complete. It's just to check whether the things are fine or not. So now q0 on 0 makes it as x, move to q1 and right. q1 will bypass all the y's. q1 on receiving a 1 will make it as y, move to the left. q2 on receiving y is going to bypass it. It is not going to receive a 0 over here since all of the y's are pending, and a moment will come when q2 will be receiving a x and it will be keeping the x as it is and move to the right to state q0 and pointing at this y currently. So friends, now to the right of the x I am unable to find 0. That signifies zeros are over. So now a single 1 is expected just before the blank. But before that we have to bypass all the y's, and we know how did we do it. For the first y we have a state change, and for all of the remaining y's we have a cycle. So let's do that. So I say if in q0 state I receive a y, I keep it as y and move to the right to a state q3, and in state q3 I am going to keep on bypassing all of the y's, and the moment will come when in state q3 I'll be coming across a single 1. So if that happens over here, when I come across a single 1, I'm going to make it as y and move to the right. So for the single 1, I have made it as y, move to right to a state q4 for the first time. And now in q4, immediately I have to compulsorily receive a blank, and if that is the case, I say q4 on receiving a blank will keep it as blank, not move anywhere. Instead will go to the final state qf and say that the input is accepted by the machine. So my friends, this is the only change over here. 0 raised to n, 1, 1 raised to n is converted to 0 raised to n, 1 raised to n, 1, and the only change is in the last part of the problem. As we can see that we have got over here one additional state q4 which is keeping a track of a single one's encounterance after completion of 0 raised to n, 1 raised to n. So with this friends, we complete with this problem. See you in the next session. Thank you.